Okay, so today we're going to look at how to write numbers as a product of their prime factors, and we're going to jump straight to the key points to explain what some of these key words mean. So, product of primes is another way of writing a number, and we know from previous learning what these words mean. So, product in maths means multiplication, means multiply. Prime, as in prime numbers. So you should have learnt what those are already. And just a reminder, prime numbers are numbers that are only divisible by themselves and 1. And we're going to look at what the prime numbers are in a second. And the last key word you need to know is factors. Now, people often get this confused with multiples. They're not the same. Factors are numbers that go into another number. So, for example, factors of 10 are 1 and 10, 2 and 5, because these numbers all go into 10. So what we're going to do before we start looking at product of primes as a whole, we're going to break down what we mean by these key terms and see what they mean in terms of the maths. So firstly, I want us to have a look at what the first 10 prime numbers are. Now the first prime number isn't 1 because it needs to have 2 factors. The first prime number is 2. Now, what's special about 2 as a prime number is that it's the only even prime number, because any higher even number than 2, you can divide by 2. And that means that it isn't prime, because don't forget, prime numbers are numbers that you can only divide by itself and 1. So the first prime number is 2. The next one is 3, because you can only divide it by 3 and 1. 4 isn't prime because it's even. 5 is the next prime number, because you can only divide it by 5 and 1. 6 isn't prime because it's even. 7 is next. 8 is even. Now, some people think that 9 is prime number, but it can't be because you can divide 9 by 3. So 9 is not prime. The next one is 11, then 13. 15 isn't prime because, again, it can be divided by 3 and 5. The next one is 17, 19. Let's see how many we've got. 1, 2, 3, 4, 5, 6, 7, 8. So 2 more. The next one up, people think that 21 is prime, but it isn't. You can divide it by 3 and 7. So the next one's actually 23. 25 isn't prime because you can divide it by 5. So 27 isn't prime because you can divide it by 3 and 9. And so the next one is 29. So those are the first 10 prime numbers. Now, the next thing you need to be able to do is be able to list the factors of 36 as an example. Now, my tip for listing factors is always start with 1 and always do it in pairs. So the factors of 36, we start with 1. 1 times 36. So that's what I mean by pairs. 1 times 36 is 36. Then go up to 2. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. 5 doesn't go into it. And then it's 6 times 6, but we don't need to write it twice. Once we get back to the numbers that we started with, we know that we're finished. So those are all the factors of 36. So if I now had to circle the prime factors, what I mean by that is it's a factor of 36 and it's a prime number. So if we look through this list, we've got a couple of prime factors here. 1 isn't prime, 36 isn't prime because it's an even. 2 is prime, so that is a prime factor of 36. 18 isn't, it's even. 3 is prime. 12 isn't, 4 isn't, 9 isn't, 6 isn't. So those are the 2 prime factors of 36. Okay, now we're going to look at what product of primes actually look like. And this should be enough of a warm-up for you. We know what primes are, we know what factors are, and now we know what prime factors are. So moving on to the next section of worked examples. So, question 1. We need to express 48 as a product of its prime factors. Now what we're going to do is we're going to do a thing called a factor tree. Now you might have seen these before. What we need to do is split 48 into 2 numbers, 2 factors. So 2 numbers that multiply to make 48. Now ideally we want one of these to be a prime number. So straight away when we look at 48 we can see that it's even because it ends in 8. So we know that we can divide it by 2. Often this is the easiest place to start. So I'm going to divide 48 by 2. And you know that 2 times 24 is 48. So that's what we put on the other branch of this factor tree. Now, whenever we write down a prime factor, we circle it. So that branch is now finished growing because 2 is a prime factor. 24 isn't a prime factor, so we have to keep going. We do the same thing to 24. Again, 24 is even, so we can do 2 times 12 because 2 times 12 is 24, circle the 2. 12 is even again, so we can do 2 times 6, circle the 2. 6 isn't prime yet, we have to keep going. And so we do 2 times 3. And this time 3 is also a prime number, so we can circle both. Once we get to this point, we know that the tree has finished growing. So that is our final factor tree. However, that is only worth one of the 2 marks. Our second mark comes with writing it as a product. Remember, that means times of its prime factors. What this means we have to do is we just write down 2, 2, 2, 2, and 3, because those are all the numbers in the circles. And we just put a times in the middle, because that's what the product means. Now, if you want it to be super flash, you could write this instead as 2 to the power of 4, because we know that there's 4 lots of this 2. So 2 to the power of 4 times 3 is another way of writing that. So you could have this or this as a potential correct answer. Both are completely fine. Now, last worked example, express 75 as a product of primes. Now, we, again, need to do this factor tree, and we can see that 75 is not an even number, so we can't divide by 2 this time. So we need to think about another number that goes in 75 that is a prime number. So going back to our prime number list, which of these numbers goes in 75? We can tell that 5 definitely does, because 75 ends in 5. So if we do 75 divided by 5, we get 15. So 5 times 15 is 75. We circle the 5 because that's prime. 15 isn't prime yet, we have to carry on. And we know that 3 times 5 is 15, and both of these are prime. So this factor tree is finished much more quickly than the previous one, but we can see that these are all prime factors. Now we choose to write them out like this. So we've got 5 times 3 times 5, or we can write that as 5 squared times 3. Okay, either of those answers is completely correct. So make sure you've got those examples written down and that you've understood them. And then what I'd like you to do is have a go at this your turn question. So pause the video and then come back and we'll mark it together. So 100 as a product of primes, we know that 100 is even, so we can divide it by 2. And we know that 2 times 50 is 100, so we circle the 2. Then we carry on with the 50. We know that that's even again. We know that 2 times 25 is 50. Circle that. 25, we can split it into 5 and 5. Circle both of those. So our final answer here is 2 times 2 times 5 times 5, or 2 squared times 5 squared. Now, just to show you that you can do this in more than one way, let's say when you started with 100, you instead did 2 and 50, and then you did 5 and 10, because 5 times 10 is 50. Circle the 5, split up the 10, 2 and 5. You actually end up with the same answer. No matter what you do, if you've done it correctly, you should always end up with 2 squared and 5 squared. Okay, so your factor tree might look different, but your answer should be the same. Okay, what I'd like to do now is have a go at the product of primes practice questions, and then do the exit card and send pictures of those to your teachers.